Welcome everyone. In this video we are going to find the antiderivative of tangent of x. So let's write that. We are trying to find the antiderivative of tangent of x, and of course we have dx. Now notice that I didn't put boundaries to this integral because this is an antiderivative. At the end we won't get a number, but rather we will get a function, which will be the antiderivative function. Alright, this is an indefinite integral. So how do we approach this? To approach this, I will write the inside as, so we have the integral, and tangent of x is by definition sine of x divided by cosine of x. Then we have dx. Here I will use the method of u-substitution. So it works like this, and you are perhaps familiar with it. We define a u, and in this case it will be cosine of x. Now we will take the derivative of both sides in this definition with respect to x. So we get du divided by dx, du by dx. And on the right, we have the derivative of cosine of x with respect to x. That is going to be negative sine of x. And if you don't believe me, you can find the derivation of this from the cards right now, also from the descriptions part. So du is going to be then, multiplying both sides by dx, negative sine of x dx. Cool. And let's substitute this to our integral, to our antiderivative. So we still have the integral sign, and instead of the denominator, which is sine of x dx, we can substitute negative du. Because we just showed here that du is equal to negative sine of x dx. So if we multiply it by a negative, we get the denominator. And this was divided by cosine of x, which we defined to be u. Cool. So now we have this integral. How can we take this integral, this antiderivative? Well, we will use the fact that the antiderivative of 1 over x dx is equal to ln x plus c, and there is a nuance that this x is inside an absolute value. This is ln of absolute value of x. And I will get to it why this is like that. And in a future video, I can prove this if you want. So if you want that, write that in the comment section. So we will use this fact. And now let's substitute. We just have u instead of x, right? It doesn't make a difference. So we get negative. Don't forget the negative. We get negative ln absolute value of u plus c. And c here is just a constant, a number basically, any number. So if we carry out this, because remember, we can't stop. We defined u. We need to substitute for it. We have negative ln, and inside the ln we have an absolute value, and inside that absolute value we have u, which is actually cosine of x plus c. And this is the antiderivative of tangent of x. Now, as I said, I want to talk about the absolute value here. The absolute value comes from the fact that the argument of ln cannot be negative. Alright, ln is defined for numbers that are greater than 0. That's why we put the negative, because otherwise we would be violating the domain of the function. And as I said, if this doesn't make sense to you, if you are not convinced, that is totally okay. I can do a video about it. But this is it for this video. We found the antiderivative of tangent of x. It is negative ln of the absolute value of cosine of x plus a constant. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.